Let us have another example. In this example, I consider two random variables x and y to be independent, and then I add them together and I have z. Assume that x and y are independent, so the joint distribution fxy of x and y is equal to fx of x times fy of y. And I also assume that both of them, they have exponential distribution. I want to see what will be the distribution of the sum of exponentially distributed random variables. This is very important because exponentially distributed random variables are observed in many physical phenomena. For instance, if you have a traffic line, and let's say this is a car, this is another car, you know that they are randomly positioned in a space. Or if you consider these points to be the arrival time of your packets, so let's say this is t1, this is time t2 that the next packets arrive, or you could consider these to be the arrival time of customers at a bank. So the first customer arrives at T1, second customer at T2, etc. So the time inter-arrivals are very well modeled to have exponential distributions. So let's say Ti minus Ti plus 1 or Pi minus 1, the difference, if I consider this as x or y or z, they have exponential distribution in lots of physical phenomena. So in this example, I assume that x to have an exponential distribution with a parameter of alpha. So here, let's say this is the value of 1 over alpha, and here is alpha. So if I plot this line, my exponential should be like that. Okay, so this is fx of x, this is x, and then for this one you could assume that you have fy of y. You could have another parameter, let's say beta be bigger. So if it is bigger, 1 over beta becomes smaller. So you draw this line and then you draw the exponential one. So anyway, this area should be always equal to 1. So if they are independent, the distribution of the sum will be the convolution of these two exponential functions. So z, which is the sum, will have a PDF. So this means that the distribution of z is given by these is equal to the convolution. And the convolution integral, so you have to, because the formula for this is integral of fx of z minus y, fy of y, dy, and y varies from minus infinity to plus infinity. This fy of y is 0 for negative values of y because of these unit step functions. So this is why I started from 0. You have 1 alpha here, 1 beta here, so this is why I have this one. And then if you multiply these together, you get this one. So you could see that these simplifies, becomes e to the power of the factor of y will become minus alpha minus beta times y, and then you will get e to the power minus alpha z, and then dz. This is constant, comes out, and the remaining part you do the integration, and then the integral will be simplified. For value that alpha is not equal beta, you will get this expression, and if alpha is equal to beta, you get this distribution. This, for value of this one, is a gamma distribution with a parameter of degree of freedom of 2. The first one is a mixture of two exponential distribution. So if you convolve this one and this one, you get a form like that. Because in both expressions, you see that the value of your joint CDF f z of z at z equals 0 becomes 0. So you start here, and so this is like what convolution does.